Hello students, so I'm back with my next topic. In the previous session I discussed about addition and subtraction of matrices, and in this session we'll be discussing about multiplication of matrices, right? So addition and subtraction was quite simple, and multiplication I would say is not that simple, but that does not mean that it's very difficult. So what do we mean by multiplication of matrices, or how do we multiply two matrices? First of all, we'll discuss the mathematical definition of multiplication of two matrices. So two matrices can be multiplied only when the number of columns, note this, in the first, which is called as the prefactor, is equal to the number of rows in the second, called the post factor. This means that this matrix is called the prefactor and this matrix is called the post factor. You just need to note one thing here, that the number of columns of first need to be equal to the number of rows of second. That is, if we have a m cross n ordered matrix, then the second matrix should be of order n cross anything, say p. This n should be the same as this n, only then can we multiply the two matrices. So in this case we have Cij entry is equal to ai1 b1j plus ai2 b2j plus so on, which can be written as in the form of summation. We can say summation of k going 1 to n aik bkj, where I varies from 1 to m and j varies from 1 to p. Okay, so this seems to be quite difficult, but don't worry, you need not remember this definition, because once we discuss the various examples you will easily be able to understand it. So what do we have the next thing? When you multiply two matrices, you just need to remember one thing, which is that once you start multiplying, the system that you need to follow is row and then column. The product of two matrices is found by multiplying the corresponding, this is an important word, corresponding elements in each row by each column and then adding them together. So the order you are going to follow is row and then column. I will discuss it with various examples, you will be able to understand it easily. Okay, now we have certain examples. See. So how do you multiply these two matrices? Remember, the first thing that you need to see is the order of matrices. So this has got two rows, this has got two rows, the first one, and two columns, three columns in fact. So the order becomes 2 cross 3. Then we have 3 rows and 2 columns, so the order becomes 3 cross 2. So since this is equal to this, number of columns in first is equal to number of rows in second, so these matrices can be multiplied. Okay, so how do we proceed when we multiply two matrices? Multiply this element with this, 1 into 0, add this element into this and add this element to this, 1 into 0 plus 2 into 1 plus 4 into 5 will give you this element, right? So what are we exactly doing? We are multiplying the elements of first row with the elements of corresponding elements of first column, which will give me the first entry of the resultant matrix. Similarly, now I proceed further. Now if I multiply the elements of this row with the elements of this column, that will give me this element, the element of the second row, first element of the second row. So we have 3 into 0 plus 9 into 1 plus 9 into 5, which will give me this entry. Similarly, you can find in this matrix as well. So now we have certain examples. How do I multiply these two matrices? See, as I told you, you just need to remember the order as this with this. So take this element, multiply it with this, that is 2 into 3, plus will always have a plus sign in between, this element into this element. So minus 1 into 5. This will give me the first element. Okay, so I forgot to remember that the order of the matrices were 2 cross 2. You need to check this first, and the order of this matrix is 2 cross 3, so we can multiply them, right? So we have this will give me the first entry A11. So this is 6 minus 5, which is 1, correct? Okay, now we proceed further. Similarly, you can on similar lines, like if I want the A second or first entry, that is A21, then what I will do is multiply this element with this plus this element with this, that will give me this entry. Similarly, you can find all the entries of this matrix. So we have another example. Here we have is, first of all, you will be checking the order of the matrix, right? So order of matrix is 2 cross 3, 2 rows, 3 columns, 2 cross 2. Okay, so what do we see here? That this is not equal to this, so these matrices can't be multiplied. So remember this thing, don't blindly start multiplying any two matrices. The number of rows of number of columns of first should be equal to the number of rows of second. So these matrices can't be multiplied. Next we have is, I have got another example. So again, this is quite simple. The order of matrix is 3 rows, 3 columns, 3 rows, 1 column. We can multiply them. So this will be 1 into x plus 2 into y plus minus 1 into z, that will be equal to this entry. So here we are, we'll get these 3 equations. This is quite simple. First equation is x plus 2y minus z is equal to 1. Similarly, you can get these 2 equations as well. Okay, so now we have scalar multiplication. What do we mean by scalar multiplication? Matrix that is obtained by multiplying each and every element of matrix A by the scalar lambda is called the scalar multiple of matrix A by lambda. And how do we denote it? We write it as lambda A, where A is the matrix Aij, and hence the matrix lambda A is lambda Aij. We have an example here. The matrix A is this. Then what do we have as 2A is, we just multiply each and every entry by 2 and we'll get the matrix 2A. The order of the matrix will be the same as the previous matrix for sure. Next we have is another example that says that if a matrix A is given as this and a matrix B is given as this, then we need to show that AB is not equal to BA. Okay, what does this mean? This is the commutative law. This is also showing, this example also shows that the commutative law need not hold true in case of multiplication of matrices. If you remember, in the last session we discussed that the commutative law holds true in case of addition of matrices. So how do we proceed? We need to find AB and then BA. So first of all, we find AB. The matrix AB is this element into this element plus this element into this element plus this element into this element. So we get it as 2 plus 6 plus 1. This will give us 9. Similarly, on similar lines, you will be able to find this matrix AB. Then we will find the matrix BA, which will get as this, and so we get the result that AB is not equal to BA. Next we have is another example. Okay, so if a matrix A is given as this, order of the matrix first of all is 2 cross 2, and a matrix B is given as this, order is again 2 cross 2, and it is given that AB is equal to BA, then we need to find the value of X. How do we proceed in this case? First of all, since this is equal to this, so clearly we can easily multiply these two matrices. Now I find out AB, 1, X, 2, 3, 1, 1, 1, 2. So how do we multiply these two matrices? I simply find out 1 plus X. So I get it as 1 plus 6. Then 2 plus 3. 2 plus 3. Similarly, I can find out these. What about BA? So BA is 1, 1, 1, 2, 1, X, 2, 3. So this gives me 1, okay, this gives me 1 plus 2, so 3, and similarly I can find out these. So what am I doing here? You need not find out each and every element of these matrices. Why? I just need to find out the value of X. So since it is given that A plus AB is equal to BA, this means that each and every element of AB would be equal to each and every element, the corresponding element of BA. So I can simply write here 1 plus X equal to 3, that is the first element of AB would be equal to first element of BA. So this gives me X equal to 2. Okay, so I've got the answer of X, but what you can do is you find out each and every element of these two entries. Also you can find out these three entries, and then you can compare so as to check your answer, which would obviously be correct, right? That was simple. So now we have some properties of matrix multiplication. We discussed in the last session about properties of matrix addition, right? So first of all, matrix multiplication may or may not be commutative. This we have already seen in the previous example, that AB may or may not be equal to BA. We need not have AB equal to BA. That is not necessary. In certain cases you might get by chance, but it is not necessary in general. In case you get AB equal to BA, then the matrices are said to be commutative matrices. And if you don't get AB equal to BA, then they are called anti-commutative matrices. So one thing important here is that multiplication of diagonal matrices is commutative. Diagonal matrices, you need to have only the elements in diagonal, rest of the elements have to be 0. In this case, we'll have the multiplication as commutative. We'll have AB equal to BA. That was simple. Okay, we have continuation of the properties. Next is matrix multiplication is associative. Associative means if A, B and C are three matrices, and I multiply A and B and the resultant is multiplied by C, that will be the same as if I multiply B and C first, say it gives me a matrix T, and I multiply the resultant D matrix with the A matrix. The answer in both the cases would be the same. Next is matrix multiplication is distributive over matrix addition. What does that mean? This simply means A into B plus C would give me AB plus AC. Or similarly, we can have the addition first, then multiply it by C, and then we'll get A into C plus B into C. Whether I find out this first or I find out this, both the sides would be equal. That means matrix multiplication is distributive over matrix addition. Next we have is cancellation laws need not hold good in case of matrices, matrix multiplication. So AB equal to AC if we have, that need not imply B equal to C, although we might have A non-zero. So if we have AB equal to AC, that need not imply that B would be equal to C. Okay, the last property is if AB is equal to 0, that is if we have the product of two matrices as the 0 matrix, that need not imply that A or B is null matrix. It is quite possible to have the product of two matrices to be a null matrix, although none of them was null, right? So that was it. Now we have certain important points. First of all is the order makes a difference. Order is extremely important. AB is different from BA. Why? Because commutative law need not hold. In case of matrix multiplication we are talking. So AB, you cannot replace AB by BA or BA by AB because both can be different. Second we have is the number of columns in first matrix must equal number of rows in second matrix. This is very important because unless we have M cross N and we have N cross P, this is equal to this, only then can we multiply these two matrices. Otherwise it is not possible to multiply such matrices in which this is not equal to this, right? Or we can also say it as the inner dimensions must be equal. These are the inner dimensions, and in both the cases this is the inner dimension. So inner dimension means this n should be equal to this n, and the answer, last is the answer will be number of rows in first matrix by number of columns in the second matrix, that is the outside dimensions. Okay, what does this mean? This simply means that if I have a matrix A, I suppose have a matrix A of order M cross N, and I have a matrix B of order N cross P. This need to be equal, right? And I perform the multiplication AB, then what would be the order of resultant matrix? You can simply judge it from here itself. How? I'll tell you. See, for AB to be conformable for multiplication, we need to have this equal to this, right? You just simply cancel this this is simply for your understanding. You can just cancel this, and this would be the order of resultant matrix, that is AB would be of order M cross P. That is the outside dimensions. So that was it in this session. As far as multiplication of matrices is concerned, I am quite sure you would have enjoyed and you would have understood the concept, but still you will have to practice a good number of questions on the topic so that you can handle all sorts of questions in the competitive exams. So do practice a good number of questions on this, right? So do stay tuned for my future sessions as well, as I'll be switching to matrices, various properties, and then we'll be switching to determinants. Thank you.